Okay.
Okay.
Anybody keep track of the Baron's number? 72, 73?
No, I don't know what it is.
It's one more than last week.
Yeah.
Yeah.
Tune in next week.
Okay. Got it. Okay. So this is the current version of the Santa Barbara Astronomical Unit Astro Hour. And we don't remember the number, so we're just going to go with it. We can fill that in next week when the Baron is back. He's visiting relatives in Philadelphia, right? Or Pittsburgh?
Pittsburgh.
Okay. So let's cut right to the talking points today.
Okay.
We do have a very close to a full moon right now.
Mm-hmm.
And so our first topic for tonight is how to star hop to some objects that won't be so strongly affected by the full moon. And that is among the brighter objects. And that is the Ring Nebula, the M27, the Dumbbell Nebula, and the Wild Duck Cluster, M11. Let's see. Let me get that.
And these are all targets we do at our campground observations these days.
Mm-hmm.
Okay.
Especially at Kachuma, since they do bird watching. We also do the Swan Nebula.
Okay, you see that okay?
Mm-hmm.
Yep.
Okay. The dang, you got to get a better pop-up. So anyway, this is the sky in the east, the rising stuff, around 8 p.m. Found an oddity of my planetarium program is that at any time of the day it will show you any star pattern that you want to look for, as if the Earth were transparent. So I got to be careful that these things are up when I have the time displayed. So the up at the top you can see Vega and the constellation of Lyra with its trapezoid. And M57 is right near the bottom two, right halfway between the bottom two stars, Shellac and Sulafat.
Oh, there it is. Yeah, yeah.
Yeah. And then right in the middle between it, where the index finger on my cursor is, that's M57. Now, for me, in a telescope at outreach, that's quite a challenging object to find while people are waiting for it, because at the low power, it looks just like a star. So you have to have a higher magnification on to be able to see the Ring Nebula. And then you pass right by it without seeing it. So, but it's worth a look. Telescopes up to 6 inches and 8 inches will easily show it, but the central star, a white dwarf, is magnitude 14. So those smaller scopes will not show the central star easily. You have to be in the larger sized Dobsonians to see the central star.
Or have a camera and cheat.
Yeah, get a camera and take your time. So then the other one for tonight, this week actually, while the moon is full, is down in Vulpecula, M27 down here, barely above the eastern horizon at 8 p.m.
Mm-hmm.
And that one, let's see if I can show that one.
The dumbbell, right?
Yeah. Let's go back to stop. This is not the dumbbell. This was the
Ring.
That's the ring.
M57, the Ring Nebula, with its central star here, the 14 magnitude one. Now it goes out quite a ways. If you take a long photograph, there's a lot of debris out here, farther out, that's still red. You can see a little of it here, but that takes a good processing and a lot of time on a dark sky.
And this is bait and switch because you won't see the colors in a backyard scope.
Right.
That's right. This is, you only see the colors in the imaging. I mean, yeah, in a Oh, I guess, okay, let's do that. Never mind, I'm talking to myself.
And that donut's about a light year across.
Mhm. Now, M27.
I understand in a couple of 100 years, the donut will pretty well have gotten big and dissipated.
I think it'll be more than a couple of hundred, but
Yeah.
Maybe a couple thousand.
but it's on the way.
Okay.
Yeah.
Now, this is the Dumbbell Nebula, which Chuck claims is named after him.
Yeah.
I don't see a dumbbell in there, except maybe the weights are on the end and the shaft is in the middle. But
Apple
It's an
core.
apple
Apple
core.
core.
Yeah.
I would go with Apple core better. It's another planetary. I believe the central star is here, and I don't recall the magnitude of it. So I don't know if it's visible or not. It looks pretty faint in this picture. Oh, Ron just showed up as asking to be admitted. So we'll see what happens here.
Ah.
Okay. So then the final one.
So those two were planetaries. Those are where an
two were
old star broke
planetaries.
off its outer layers. And the next one is an open cluster.
Yeah. Let's see here. Okay.
Hey, there he is.
Hi, Ron.
Not like I haven't been trying. Does this ever happen to you, gentlemen, where your computer or your inbox just decides to take you out? That long-standing May 17th talking points, which had our big long link number. It found it in some strange file. But gentlemen, have you started the program already? I can join in.
Yeah,
right.
we're in the first stages of it.
Okay.
We're trying to
Fumbling around
guess
here.
which
All right,
number
did
this was.
Did everybody get introduced, or shall I do that?
Now go ahead, introduce us.
All right, we'll start with you, the beloved longtime president. This is my granddaughter. You want to look into the camera and say hi to everybody? She's, yeah, there's.
Hello.
Was she about 2?
She is 5, right?
Hi.
5? Wow.
You're on.
What's your granddaughter's name?
Her name is. Tell them your name. Giselle.
Giselle?
Giselle, and her older sister is Giovanna in the other room, and my son's at work. And what do we got on the screen? Is that our president on a bad night? That looks like it.
It depends what the night was. This is the M11, the wild duck cluster.
Oh, you guys were into it already. Well, anyway, you're the president, knowledgeable cat, Jerry Wilson. He actually has a PhD, but hates to be called a doctor. His wife is Pat. Longtime world's most prolific outreach coordinator, Chuck McPartland, for you folks that don't know, on this 11th day of July. Also with a wife named Pat, waving at us. Pat, who's our merchandise manager. Recently retired science teacher and lab technician up at Westmont College, Tom Whittemore. Are you on board?
Hi. Morning.
Oh, there he is. Okay. And then we've got stalwart supporter, big telescope owner, victim of some recent injuries and back with us, I hope. Many years member Bruce Murdoch happens to be president of the Santa Barbara Theater Organ Society. And I believe your wife is Bonnie.
That's correct.
Okay. Is that everybody on the screen? Did we get Chrissy on board?
Yeah.
Okay. And we've done the intros. We're having a big Dargan.
The only thing we need from you is what number this is.
What? No, oh, it is.
We're
big
number
step.
1.
We're keeping tabs on it. It's number 72.
Okay.
It's about a year and a half almost. Let me just run down what we may get to today. 3 stars of Scotty's Triangle is a definite talking point. A second horse in the night sky. Is that possibly maybe a pony? A couple of Jupiter's moons going to pass by, tracking 3 bright asteroids. Moon's hitting its perigee, I guess, Wednesday. And 1 huge meteorite, which is not in Chuck McPartland's collection.
Oh, that thing is huge. Yeah.
So what did we start with? And I'll join you on my talking points.
Well, we're just finishing the 3 brighter objects to try and spot during the full moon.
Oh, okay.
And we're looking at the 3rd one, which is M11, the wild duck cluster. And it's an open cluster, as Chuck points out. I guess when you look at it visually, it resembles a duck. But when you look at it in this photograph, I don't see the quacker.
Well, they process a lot of these photographs too much, and you lose. You know, they want to bring up the background, and you lose the.
Yeah, the pattern.
You
I
lose the
think-
pattern. Yeah.
Yeah, the pattern's a V. It's a V of flying duck.
I was going to say, this is from, I think, Admiral Smythe in England in the 1800s that gave it the wild duck's name.
Well, there's
Right.
kind
Thought
of
it
a
looked
V
like
right
a
here.
formation of flying ducks.
Okay. There's kind of a V right here.
Yeah.
Mhm.
Okay.
Yeah, in a moderate telescope, is pretty obvious. This is just an overwhelming image, you know.
All right, you brought in the moon. Is the moon involved in this? Is it in that? It's not in that picture.
No,
Well, the moon
there's
is
no
not in
moon.
this pic. Yeah. The moon is brought in because it's going to be a full moon here shortly.
Mhm.
Right, perigee. What does that mean?
Close approach.
Closest to Earth.
Therefore, biggest to us.
Yeah.
No,
Yes.
bigger. It's not the closest perigee of the year, but
Okay, so it'll be Wednesday morning, I think, before dawn, about 2 o'clock or so. And all these other things that are in. But star hopping is not the story we're talking about. It's not Jupiter's moons. So
no, we're
okay.
doing the Scotty's Triangle part.
Oh, okay. Let me find that and I'll join you guys. Continue with
This
that.
is a confusing picture.
Why is that?
This is, well, this is the moon,
Yeah.
and
Well, this is talking about the occultation in
all right.
Sagittarius. This has jumped to another subject.
Well, we're talking about the moon and it being full. And
Okay.
so this is essentially a full moon, but it is, as Chuck points out, it's an occultation. Here's the constellation of Sagittarius, and this is the spout, kind of losing the red pattern here.
Like a monstrous elliptical.
I
Yeah.
think
Yeah.
that's the handle. The handle of
The handle, that's right.
Yeah.
And the moon is moving this way.
Mhm.
This is about 10 or 20 minutes before it occults this star here, which is Tau Sagittae. So this is a 3.3 magnitude star. So you should be able to see it okay. This is 3:11 a.m. from Santa Barbara here. And on Wednesday evening, the 13th. I guess that's
Or Wednesday
Wednesday
morning.
morning. Wednesday
Yeah.
morning, the 13th,
The 13th of June,
July.
July.
July. Oh, all right.
You can see the calendar way up at the right, see July 13, 2022. Does that show up?
Yep.
How do you see
Okay.
July 13 when today's only the 11th?
I can set the planetarium software for any date and time I
Okay.
want.
This is not a real photograph. This is
No.
okay. I got it. I got it.
No. And I've got the bullseye on the star, and you can see the data on the star right here. And it is called 40 Tau Sagittae. But if you're a fan of the SAO or the HIP or any of the other things, they're all listed here if you dig them up.
And some of these occultations are pretty spectacular to watch, especially if they're a grazing occultation, where you go to the path where the star just skims the edge of the moon. This one's going to be a pretty direct, just occultation.
Right.
And it's fun to watch the reappearance.
Mhm.
You position yourself along the limb of the moon, especially if you've got a dark limb on the moon. Here, it's going to be all pretty bright.
Yeah. One of the most dramatic things I ever witnessed when I started out in the 60s was the moon occulting Saturn.
Yeah.
Mhm.
That was very dramatic. It was very direct.
Occulting, is that the right word? I mean, it's big enough
Yes.
to cover half a degree of sky a night, and that
Yeah.
would be a lot of things.
Yes,
Yeah.
it does.
That's
Yeah,
what occult,
So Ron, the moon moves through its diameter in an hour. So the occultation would last for roughly 1 hour, just rough.
Oh, and we lose sight of it because it's behind the moon.
Yeah.
Yeah.
Something-
And it's, for a well-known star like this one, it's not really any useful scientific data, maybe a little bit for refining the orbit of the moon.
yeah.
Uh-huh.
But often, when the moon occults some of these other stars along the ecliptic or along its path through the ecliptic, there have been discoveries that the stars are double because you see a step in the occultation if
Right.
you're taking brightness data.
one of the things that they used to do in the 60s and publish in Sky and Telescope was when there was a bright star occultation like this, they'd do a photometric recording of the brightness as it disappeared, and you can see the diffraction pattern created by the edge of the moon on the starlight, which comes in as a plane wave. It's quite dramatic.
Well, are any of you gentlemen going to focus on the full moon to see those flat floor craters that you mentioned this week?
Yeah, I'm not a full moon fan. It hurts. All my scopes are real fast scopes.
Now we'll probably have the moon in the shots at Westmont for some people, but it's rising a little later.
Apparently, the moon bobbles away. It's called libration. And,
Right.
And this time we get to see the more of the top.
Yeah, good segue.
What?
Good segue.
Okay.
I just got
By
a
the way,
text
your scopes are fast. Well, mine are half fast.
Half as fast.
I just got a text from Tim Crawford saying that we need to explain what the limb of the moon means. I'm not sure that that's so obscure, but it means the edge of the moon.
Right.
Yeah.
It means the horizon.
Oh, of the lit moon. Horizon, black.
The edge, just the edge, wherever it is, Ron. It doesn't have to be the lit part.
Right.
Well, that's strange. I was watching one program with Neil deGrasse Tyson, and he was naming some medical thing, which was 9 syllables long, and he could pronounce them. He says, but in astronomy, if we see spots on the sun, we call them sunspots. It was simple. I like that.
Well, I learned some new craters, Jerry. Cremona, Briantian, Pascal, and Sylvester.
Yeah, this is a portion of the moon. You can see the whole moon down there, and then the square that shows the blow-up area. It's right on the limb of the moon, and the moon is in this particular time, and at this when it's full, this phase, it's tipped way toward us. So we see craters that we cannot normally see because of that.
And Ron,
there's Cremona, and you can see little hillocks, little ups and downs on the limb. And those are, you're looking at mountain ranges and craters in profile.
Yeah, just some awesome figures here. 2 miles high around the central peak of Pythagoras crater. Pythagoras.
Like the Pythagorean theorem?
Yeah, I know exactly what the Pythagorean. I've just never seen it written like this, and it becomes a symbol block from it.
He was the guy that always walked diagonally across the lawns.
Yeah.
and Ron, you see the crater called Cremona?
Yeah.
Yeah, that's where some real famous violin makers lived.
Oh yeah.
It's also a milk-like flavor for coffee, isn't it? Cremona? I'm not sure.
Cremora.
Cremora. You're right. Okay, but can you imagine 2 mile high crater on the edge, 3 miles below the rim on the floor? You know, that's other than Everest, we don't have any contrast like that on Earth, do we?
Well,
yeah, but they don't have wind. They don't have erosion.
And 1/6 gravity, so you can pile that stuff up.
Yeah.
And we didn't land any of the Apollos in this region, right?
No.
Not in Pythagoras.
Pythagoras.
So my understanding of where these central mountain peaks came from, why they're there, is that in some cases when the impactor, whatever it is, comes in and hits the moon, it acts, both the impactor and the moon act as if they were a liquid. Maybe they are liquid. And they rebound, and if you drop, if you've ever seen these stop motion things where they drop a droplet of milk into a plate of milk, and it splatters up into a crown, and then up in the center you see the drop rebound and go up. Apparently, as that drop goes back up in the rock, it freezes. That's when it turns back into a solid, and that's where you get the central peak. It's the rebound.
And it's a sign of a very energetic impact.
Yeah.
But we all saw Apollo 11 and the follow-up landers jumping around in what looked like a sandbox. There's the dust everywhere. Where did that come from?
That's pulverized moon.
That's from impacts.
Yeah.
And so a lot of what we're looking at here, these round circles, are they piles of sand or dust?
No,
or
no, they're
stop?
mountains, Ron.
Yeah,
So it resolidifies, like you said.
yeah, yep.
And the
The,
dust on the moon is really abrasive because it contains a lot of little nickel iron spherules and spikes of glass and stuff like that from these impacts.
Well,
Also, you got a state diagram or a phase diagram, like solder. 6337 is eutectic, so it freezes at one temperature. But when they used to use solder for body work on cars, they use 90% lead solder. So it would go through the mushy phase where they spread around, and you get the same thing here. You got a whole mixture of different kind of rock, and so it's mushy. It's not, so it doesn't freeze at one temperature. So when it comes up into a peak, it's got enough solidity it stays there, then it probably freezes.
Mhm.
Well, I'm going to go out on a limb and say that I think that probably all of the Apollos from 11 on, where we landed on the moon, came back with rocks. Would I be correct? Starting with Neil and Buzz, did they bring rocks back?
Yep,
They brought thousands of pounds of rocks back.
Okay, well, they also brought back on their spacesuits, unless they cleaned them off in the LEM, they brought the dust.
yes,
Oh,
they
yeah.
did.
And it would probably measure out to be the same thing as the rock, only in dust form, right?
No, it's much lighter, but
Yeah.
it was much more dangerous because it's very abrasive.
And
those,
conductive.
Yeah,
and those footprints they left are going to be there forever, or they ever erode somehow without
Well,
wind?
micrometeorites will erode them.
Right.
yeah.
Micrometeorites.
Someday they'll get hit with little meteors.
Yeah.
And this visualization studio that made that image, you can access their website and you can enter any time and date. You got to do it in universal time, and it will show you what the moon is going to look like very precisely with libration and everything. So it's pretty useful if you're a moon watcher.
Yeah.
Do you understand that the moon, I think, is going away from us slowly?
Yes.
About an inch a year.
Yeah.
Mhm.
An inch a year. That's kind of frightening, considering everything is closing in on us from Andromeda and the sun.
No, it's losing energy the early tides.
I wonder how they figure that out. An inch a year.
Well, Ron, we can measure the distance to the moon to within millimeters now that we've got the retroreflectors up there and powerful lasers.
Yeah. Oh, there's one of our outreach coordinator's incredible meteorites. When we talk about this sucker, it's the Willamette. And I've heard a lot of news people doing news stories from Central Oregon calling it Willamette. I used to live up there. Also,
Oh, you did, huh?
huh?
I said, oh, you did. I didn't know that.
Yeah, I spent 3 years up in Oregon, 4 years actually, counting in a couple little towns in that very valley. And there's a river that goes through there that goes through Portland and hits the Columbia.
There's some very pretty parts of Oregon.
I guess that's an Indian name too, or the Tomanoas.
That's the Indian name.
Okay, and
Indians knew about this long before the white men started to drag it around and fight over it.
well, it looks older than dirt to me. And where have I heard that?
So all of the cragginess in that is where the carbon is burned out of it, or graphite.
No, in this case, there's you get various alloys of the nickel and iron, and there's also some sulfur in there. And the one called troilite, I think it is the alloy that has the sulfur in it. And when it's exposed to rainwater or moisture in the air, you get sulfuric acid.
Wow.
And it eats out these cavities in the troilite.
Uh-huh. So this picture is the largest meteorite ever discovered in North America. And
17 tons.
This one is on display at the American Museum of Natural History in New York.
A load 17 tons, harder to get. Another day older. It's how much it weighs.
Deeper in debt.
Deeper in debt.
So apparently someone found this meteorite, but it was on someone else's property, but he realized the value of it. So he spent some time dragging it over a quarter mile or a half mile to his property. And then the original property owner, the other property owner, found the trail where it was drug, and they had a big court battle. And the proper owner was awarded the meteorite, but by this time it had been loaned to the American Museum, and so the local Indian tribe who claimed it was theirs, the Clackamas Indians. They were awarded actual ownership of it, but they will not see the meteorite back in person until the American Museum takes it off display.
Oh,
I've got a trivia, Terry. I've got a trivia question for Ron.
Okay,
The song you were just singing, who made it famous?
Tennessee or
Tennessee Ernie Ford, correct. Good job.
how you win on the word when you play password ton. You can say anything else, but 16 gets it or something like that. My question for you gentlemen is something this big. Well, if it doesn't wipe out dinosaurs, because it's not that big, it should at least leave a crater somewhere.
Well, if you read the little blurb that was in Jerry's write-up, this probably hit on a large ice flow, a large glacier during the glacial
During an ice
period.
age.
And the way it got to Oregon was basically floating on an iceberg during a big flood.
Geez.
So I think they call those intermittent or something, where big boulders are transported by flowing ice or flowing water and then deposited somewhere where they're not supposed to be.
Might have been how we got it or how the Indians got it.
Yeah.
Well, you go up, hike up Mission Canyon, and you see huge boulders. Say, I
Right.
wonder how they got there. Same thing. They were floated along on mud.
Right.
The big meteor crater in Arizona, did that leave us a rock?
Well, it left a whole bunch of little rocks all over the place, and one that was car-sized.
And then the one in Russia in 1908 was huge, but it just totally vaporized, I guess,
In
right?
the air, yeah.
That one may have been more commentary because it didn't leave a lot of nickel iron debris.
Now the one in Arizona
goes
has a very interesting backstory, the Barringer meteor crater.
Right.
That they associated. There was a lot of debate about whether it was a volcanic crater or a meteor crater. One guy decided it was a meteor crater, and so at the bottom of it would be a massive deposit of iron ore. And so he immediately bought the land so he could mine the iron. But it turns out for some reason, there was not a large single concentration of iron. It was shattered and spread out in small particles like a shotgun blast. So he never really made any large ore strike on it. But the mine shaft building, what's that?
That was Barringer.
Right.
He was on the survey crew, and he bought the land, and his family still owns it. He kind of went bankrupt, but his family at least is making a go of it.
Right. And Gene Shoemaker, who studied that, led him to the idea that the moon was pelted by things and not, a volcano.
Yeah.
So anyway, when this meteorite hit in Arizona, it just missed the visitor center.
Yeah. It also left a trail of microscopic nickel iron spherules that goes all the way to Kansas.
Oh, it's what, about a mile across or more?
Yeah.
A question about meteors, you gentlemen can answer for me. I learned about iridium, a very rare metal, an element that is not very plentiful on Earth, but it's everywhere in meteors. In fact, it's how they discovered that 65 million years of giant meteor wiped out the dinosaurs, because there's a layer of iridium. What is iridium, and why is it rare here? Do we know?
It's a metallic element.
Look at these gentlemen. Ladies and gentlemen, thanks for
metallic element.
Yeah.
Yeah.
They used to make phonograph needles out of it.
Yeah. Ron was this iridium layer was originally discovered by one of the Alvarezes in Gubbio, Italy. But it's all around the Earth at that particular time period.
Yeah,
along with a bunch of soot.
Right.
It's a KT boundary.
That's
part
it.
of the nuclear winter that followed the collision with Earth, and it lasted years. And I guess wow.
Yep.
Hey, it's time for one of President Jerry's silly science cartoons. He gets. Let's see if you figure this one out. Is this the one I didn't understand? Ladies and gentlemen, thanks to a fossil that yielded, I can barely read this, bone marrow, years of research, and of course, your generous funds, I present to you a baby stegosaurus. Finally, after millions of years, a dinosaur walks the earth again, and you guess what comes through the window at that very moment, wipes it out. You're right. Okay. Some days you just.
It was not meant to be.
What?
It was not meant to be.
Oh, that's true. There's several other of your cartoons. You want to go through them? The Pyramid Scheme, kind of silly. Sports Injury, and you'll never guess who used to play basketball before he decided to go into physics. Or whatever you call up, I'll match. Here we go. You see, it's easy, Pharaoh. You get 10 friends and you add a block, and then each of them gets 10 friends and add another block, and doggone how those other pyramids get built without this guy in the background.
It's called a pyramid scheme. Isn't it?
That's how it works. Acme, yeah, good old Acme. Got any more, or you want to go back to the hard stuff?
One more.
Okay, here it comes. I won't even look at my notes. I'll just read it off the screen. Aha, who in the world, unbeknownst to most historians, Einstein started down the road of professional basketball with the Oakland, whatever they're called, Golden State Warriors, before an ankle injury diverted him into science. Here he is in the middle. He was short, had a lot of white hair, but boy, could he sink a two-pointer. Three-pointer, I guess. There you go. So are we done with the meteors? You'd love to have one that size, wouldn't you, Chuck McFarland?
Meteorites.
Meteorites, that's right. Meteors, they don't make it to Earth. How many are in your collection?
Oh, about a dozen.
Well, you showed them to us one night in a special program at the club. Uh-oh. Now, this is the one I didn't understand. The staff, a couple guys saying it's an issue fast to comprehend, and then everybody looks depressed and downtrodden and blue. And of course, one guy says to the other, employee morale is low. We all feel so significant. Is this because
Insignificant.
Insignificant.
Oh, insignificant. Okay, I got that. But is it because of the web in space?
No, it's
No,
because
it's
of
astronomers
space
looking at the
itself.
universe.
Yeah.
Oh, okay.
And all of this equipment.
In the old days, Hubble and before earlier, did you actually look through the rear end of a big long telescope like that?
Oh, yeah, that was, yeah. That era ended when the 60-inch came up in Mount Wilson, the reflector. Up until then, they built refractors up to about, am I getting a feedback here?
You are. Well,
Yeah, somebody's microphone is
it went
feeding back.
away.
Too bad, I don't know where it's coming from.
So reflectors require a side mount lens, it's obvious, because of the
No.
angles involved.
No, Ron, no, they can be Cassegrain.
They can be what?
Cassegrain design, the eyepiece comes out the back. Just like my big telescope.
Well, but right in front of that lens would be the mirror, the back end of the mirror, wouldn't it?
There's a
No,
hole in
the
the back end of the mirror
Career play.
and a secondary mirror that brings the light
Yeah.
out the back.
Okay, but I have yet to see one where you look at the tail end, like in the old days of your.
That's my scope, Ron.
Yeah.
What's
Big
everybody-
black
My scope, two of them, three of them.
Yeah, take a closer look at the next outreach.
Bruce, Bruce has one
You
that
know-
you look. Okay,
But diagonal at the back, so you look at it sideways, but you're looking at the image on the back scope.
okay. But Hubble did use a camera, right? Or something that printed on glass where he wrote his little notes about red shift and all that.
Yeah.
Gentlemen, would you like to talk about an Earth-size exoplanet being discovered? Kepler 1649c, since we've had so many recent speakers about exoplanets. It's orbiting its star 300 light years from Earth. Star is about a quarter the size of our sun, so I guess it's a red dwarf. And it's, let's see, just 1.06 kilometers. No, what is, I can't read my own right. Larger.
It's 1.06 times the diameter of the Earth.
Oh, there you go. 1.06.
Essentially the same mass as Earth.
Gets 75% of our light, or its own light, I guess.
No.
But it's in the Goldilocks zone. They know that.
Its star is dimmer than our star.
But it's a red giant, so it puts out of infrared.
Yeah, it's a red dwarf, and
Dwarf, I mean, am I saying?
Yeah,
and it's at a distance from its star that's about as far as Mercury is from our sun. But because it's a much dimmer star, it doesn't get as much insulation as we do.
For some reason, I think life would be in better shape around a red dwarf, but you don't get, huge coronas and
Oh,
blasts.
you do. They're often much more active than a
Yeah.
star like ours.
Oh, really? Even though there's less light, okay. And it's obviously in closer, right, in that zone?
Yeah, you can see it's a size comparison.
Yeah,
And we don't know if it has that atmosphere yet?
no. Don't know anything about it yet, except for the fact that it's about the same size as Earth, and it's also in the Goldilocks zone, where if there's water, it could be liquid.
Now, this is the kind of target that the James Webb could potentially take a spectrum of and detect what's in the atmosphere. And so coming up Tuesday at the museum at 3 p.m. for AU members, you can come to Farron Hall and see the first images coming down.
Wow. You don't imagine they're going to try to zero in on something like this early in it, do you?
Sure. They did an exoplanet. They did Stefan's quintet. They did a planetary nebula. So they're gonna release, I think, 5 or 6 images that they took.
Wouldn't it do a better job if there was some sort of a little occulting disk in the distance, like that other satellite mount observatory they're going to launch? You know, the one that's going to shut out the distant stars so you can see the planets around it. You know what I'm talking about?
But you know, that isn't the primary function of the James Webb. So they probably, well, I don't know. They may have an occulting disk, but I doubt it.
Well, the brightness of the star washes out everything, pretty much.
Yeah, well, if you've got enough resolution, you can sneak in on it.
Yeah.
The trend,
Apparently, we've seen a lot of exoplanets that are about the size of Earth, and a lot of exoplanets that are in their Goldilocks zone. But this is one of the few, if not the only one, that's both the same size as Earth and in its Goldilocks zone. That's why it's getting the attention here. And I'm sure because of that uniqueness, it's going to be on JWST's list.
but that's an artist's rendering of the Kepler planet on the right. You just took a guess. Said it
Just
was
made
brown.
up.
Yeah.
When they do those renderings, they do the planets in sort of brownish and red colors if they're orbiting a red dwarf star.
Really?
Yeah.
Why?
Well, because that's what they'd look like.
They wouldn't be, it wouldn't look like ours, blue?
No. Mm-mm.
So their sky wouldn't be blue if they were on the planet, right? Be like Mars?
Maybe, maybe not. It depends what they have in their atmosphere.
Mars's sky is not blue. It's what, pinkish?
It's kind of light bluish.
It is?
Yeah.
Okay.
Ironically, Mars sky is reddish in the daytime and blue at sunrise or sunset.
Really? I thought the blue on Earth came from the oceans.
No.
No, it comes from the fraction in the atmosphere. Scattering the atmosphere.
Scattering. But the blue on the oceans probably comes from the sky then, the other way around, right?
Yes, reflection of the sky. The ocean water is blue.
What is?
Water is blue.
Water
It's
is
a light
blue?
blue color. You get a big pad of water and
Your voice is breaking up, Bruce.
Pardon?
Your
Your
voice is
microphone is
breaking up.
really breaking up.
How does this sound now?
Sound
Same.
like Neil.
Oh, it's
Sound like Neil climbing down the level ladder in the first. There you go. I don't
I
think.
must connect. Does that help?
No.
Oh,
I guess we didn't get that story about the Kepler 1649c in time to ask Dr. Zellum from JPL, who gave a great report. And at our meeting on the weekend over Saturday in front of Palmer Observatory up at the museum, a very limping Tim Crawford came in and said he really loved that talk. Everybody I know that came along and saw it, they said it was funny. You know, there's a program called Nessie, N-E-S-S-I, and he said, here's a picture of the Nessie, and it's the dinosaur in the Loch Ness of Scotland. Got a big black hole and a blazar. I think this may be the first time I heard of a blazar. What's the other? No, what are they? Solar system. Anyway, it's S514-81 in the center of an OVB, an optically violent variable. Hope you gentlemen don't mind changing because this stuff fascinates me. Galactic nuclei, monster black hole. would swallow up our solar system like a gnat. So it's not, what's the other AZARs I'm thinking of?
Quasar and blazar here. So the OVV optically violent variable is optically violent variable quasar. There should probably be a Q on the end of that.
Okay.
Well, I thought everything in a black hole went down to a single point.
Well, it might inside. We just don't know.
Yeah.
Our math is so limited that the only thing we can put in there is a singularity. But I personally doubt it. I personally think it's much more complicated than that, what goes on in there.
Yeah, Ron, this is in effect, the event horizon, which
So
for our black hole in the center of our galaxy is about the size of the orbit of Mars.
Yeah.
So this would be a rendering of how much weight and matter is in there, the mass that if it were staying solid.
This is a rendering of the diameter of that event horizon, and you can see our solar system, the whole thing, out to Neptune or Pluto, depending on what your faith is this little small thing in there. This is a humongous thing.
Okay, so
You can quote me on that.
For the benefit of folks who, like myself, don't totally understand all of this, the singularity, that's another one. They'll come up with the serendipity, yeah. Singularity is where everything really is, a point in the middle, but the event horizon, what?
Maybe.
Okay, but the event horizon, as described.
We can't.
Well, I know we don't know, but as the definition is that's the round the corona or whatever that shell is.
The event horizon.
Event horizon, that's where everything stops, right? As you're entering and you're gone and there's no way turning. You can turn back possibly if you have enough power in your rockets before you get to the event horizon.
If you're inside the event horizon and you're looking out, you can see the whole universe. Just the whole universe can't see you.
Ooh.
This is where you can escape because the escape velocity exceeds the speed of light.
Yeah.
That's why it does escape.
Right. If you passed the event horizon, you wouldn't notice anything except that you were stretched into a piece of spaghetti and killed. But short of that, you wouldn't notice anything. It's not a real thing. It's just where your vision is forced to stop because there's no light coming out.
And the spaghettification would mainly occur if you were near a small black hole. A very large one, you might not even have that happen.
Yeah.
Until later.
So black holes come in a complete range of sizes from submicroscopic to things like this. And the lifetime that the black hole has, they don't last forever, is proportional, not directly proportional, but follows the size. Little teeny ones produced at CERN are there, and then they disappear within some very, very small fraction of a second. Other ones can be the size of a baseball or something, or a BB, and they could last for like the billions of years. This one, big like this, it would be very, very long time before it evaporated.
Well, with all due respect, Mr. President, you just said we don't know to a lot of the questions I had about it. How do you know what you just said?
We don't know what's inside, but we know how they act as a black hole from the outside.
I gotcha. Would hitting the event horizon be similar to hitting the speed of light if you could hit your ride somehow without having all the energy in the universe?
I don't know about that.
Because it doesn't time stop there too?
Yeah, I remember reading, if you were coming in a ship or event horizon, to you, it appeared that you never got there. I mean, you'd flow down and down, down, down.
That's how it would look to your friend watching you approaching the event horizon. If you were in the spaceship approaching the event horizon, all you would notice is that the universe outside of where you're going is speeding up. You'd see galaxies rotate, you'd see them move, and you'd see the collision of Andromeda and the Milky Way before you reach the event horizon surface.
Wow. And they think the Big Bang followed the biggest version of this, the whole universe was in a point with probably one gigantic event horizon, I would assume. It's going to make everything, right?
Well, that's kind of speculative, but
yeah.
till we come up with a better thought. I'll be doing on time. gentlemen.
Yeah, I think Big Bang is more like a quantum fluctuation than like a large black hole, but we don't know.
Well, it's certainly the type of thing kids just love to talk about at star parties. Incidentally, how did it go?
Oh, we
Saturday
had 260 people.
Fantastic.
Wow.
And how many of them were college students needing extra credit?
None.
None? Did Sean Kelly, our
Well,
Professor-
school isn't in session, Ron.
there's a summer school, I took it once.
Well, Sean wasn't there, and there was nobody for credit.
Be darned. So tourists, turistas showed up. People in
Tourists and
shorts.
locals.
And what'd you show them?
Well, we had a lot of moon because it was quite bright, but we had M13, we had Comet Pan-STARRS, we had the Ring Nebula. So people were wandering around to various things.
Okay. Are you any of you, before we go to the next, any of you going tomorrow afternoon to see JPL feed?
Well,
JPL.
it's for AU people tomorrow at the museum at 3 p.m.
I know, that's why I'm asking you guys. You're all
Yeah.
over. So are you going?
Yeah,
And there's
I
another-
try to make mask and all.
yeah, in Farrand Auditorium.
oh, it's in Farron, our little
Yeah.
place. All right.
Yeah, Fleischman is taken up by the minerals and gem display.
And our own Chrissy Cook is gonna be one busy lady.
Yep.
You wanna go out to Jupiter and check on the Europa and Io, a couple moons?
Well, first let's look at this picture.
Oh, okay, what is that?
It's an artist rendering
Sure.
of the black hole we just saw.
Oh, that we just saw, that monster sucker. Whoa.
Just discussed.
Yeah.
Yeah. S514-31 or 81.
So you can see the accretion disk, and you can see the jets at the poles.
And one of those would be pointed towards us for it to be a blazar.
You mean we get the shower of that from that far away? How far away?
Essentially, yeah.
Would this be life threatening to us?
You're breaking up too much.
I think he said, is it life-threatening? It would be if it was very close.
It's 10,000 times bigger than the Milky Way's central, what do they call?
Black hole.
Sagittarius.
Yeah, Sagittarius A.
Sagittarius A is in the center, and most,
Well, Sagittarius A star.
a black hole is labeled as a star?
A star. It's an asterisk, so you pronounce it A star.
Oh, really? I thought that was a typo. A and star were together, it's all one word. How far away is this monster? Way on the other side, right? 10 billion light years back?
Yeah,
Okay, and quasars, that was the other word I was looking for, Qs. What's the difference between a quasar and a blazar? Blazar is just the ultimate quasar,
No,
right?
blazar just happens to be pointed towards us
Oh,
much more directly.
and if it were close, how do we know how close it would have to be? Just a few light years and we're toast, right? Literally.
Oh, it depends on the size of it and how active it is, how much it's accreting, how powerful the jets are.
I see.
I mean, you see those pictures of Centaurus A, and the jets extend well out of the galaxy.
Well, here's what I don't understand. Oh, here we go. Let me do my not understanding. If it's that far distance, it's that far back in time, how did it build up so big a black hole then? You think it
that's
would
the question. That's the
Good question.
$64,000 question.
Okay. Look at
Back
the
then, you
moon.
could make stars much more massive before they blew themselves apart, because you didn't have metals, you didn't have the elements heavier than hydrogen and helium, and they could collapse directly into black holes. And you could have had gas clouds that just collapsed directly into black holes without going through a stellar phase. So part of it is that.
But I understand that even some of our star clusters in our own galaxy and in other galaxies have a black hole, and yet some of the small, what are they called, orbital galaxies that go around us in the local group don't have a black hole in the middle?
Most of them do.
Most of them do.
It's supermassive black holes that are in most galaxies, but there's black holes all over.
And that's not enough to explain the problem in weight distribution and gravity, and so they come up with with dark matter.
Right.
See, the thing I don't understand about, I understand black holes are everywhere. There's millions of them, supposedly. We just can't see them.
Right.
Yeah, that's true.
So why can't they be the understood missing link?
They're not enough. If there were that many of them, we'd see the effects in lensing and other things.
Oh, is that right?
I remember reading there are more black holes in the universe than there are stars. And some, like they're the size of balls. All
Bruce,
different.
you're breaking up like crazy.
Oh, how about this? That work?
Yeah.
Actually, you sound like Stephen Hawking. Well, we're on Jupiter now, gentlemen, so let me find it here.
Yeah, this particular event is at a time when we won't be able to see it.
It's done? Is that what you said? You're open?
No. It's at a time of day when Jupiter won't be visible.
Oh, okay.
Oh, the picture you're talking about?
Yeah.
Yeah, this is at 9:30 in the morning on 7/12. Jupiter will be way in the west. It will be daylight. So you can certainly see Jupiter with a telescope. Matter of fact, I like looking at them in the day. You probably can't see Io. Io is going to be just about to go behind Jupiter. But we have a number of these things going on at this time.
And you can see it during the day. Amazing. I had no idea. I thought our sun would blank out everything during a sunny day with no
Jupiter's
clouds.
pretty bright. Jupiter and Venus, Saturn too, but you don't see the rings.
Yeah.
Really? Okay.
So this is on the next day, July
But it's at 7
13th.
p.m. our time when Jupiter was below the horizon.
Yeah.
In the northwest of Cetus, the whale. And
Yes. Jupiter rises after midnight.
magnitude, is it minus 2.5 magnitude? Is that?
Yep.
That's really bright. What is the moon's magnitude? Anybody know? Does it have a variable?
Minus 16 or something like minus 11 or minus 16.
Minus 13 when full, Chuck.
Okay.
Yeah, when full. Yeah.
Does our sun have a magnitude number?
Yeah.
Minus 26.
26. Wow. I love it. Okay.
That's logarithmic. So
What is the circlet of Pisces? Is that an asterism?
Circlet. Yeah, we've covered that a couple times before. It's a part of the constellation of Pisces.
But as usual, all four moons will be out there, right? With their shadows. Only two of them will occult Jupiter, if you want to call it that, or transit.
No,
all
just
four can do that.
yeah. This one, even though we can't see it, probably it's going to be at 6:30 a.m. on the 13th. This is Io, and it's got a shadow on the surface of Jupiter, and it's just about to enter and pass in front of Jupiter.
And we had no idea that was a steaming ball of lava bursting volcanoes until Cassini got there. Did we know?
No.
Voyager.
Voyager gave us that.
No, actually, and that was predicted by Stanton Peele out at UCSB before the Voyager imaged it.
Wow. So I doubt it would be possible to land on Io, even in a spacesuit. You'd probably be like landing in Yellowstone right now.
Yeah.
Yeah.
Is Yellowstone one giant, the whole park at Caldera, which means a volcano about ready to blow? Have you been following those scary stories?
Yeah, it's a super volcano. There's a big blob of magma under it.
And rising.
Would you have to say, Bruce, you're coming in now?
Am I clear now?
Yes.
Yeah.
I don't know what I done. I wiggled the connector.
Well, there are demons besetting all of us.
I'll spray it with contact cleaner when I'm done here.
Are we doing starry hopping, Mr. President?
No, just showing the second to the smallest constellation, the second horse constellation.
Okay.
Well,
the horse. Yeah, right. Okay.
With its brightest star, Hittlefu, whatever.
Okay.
It's near M15, but M15 is actually in Pegasus. But this is the second smallest, number 87 out of 88
Got it.
in the night sky. no Messier objects, no pattern that it's named after. So if you want to find an asterism in here and name it, we can all try and have it go viral.
Yeah.
It's
Here's your chance.
Pegasus is the constellation, and this is an asterism now.
No, this is another constellation, Ron. It's the second smallest constellation.
And it's another horse?
Yes.
Yeah. Means small horse in Latin.
Here's Pegasus over here.
Flying
Yeah.
horse.
It would help me if we had the cartoon or the design of whatever portraying, but I'm sorry.
Well, it looks like a small horse's head, kind of, in many of the pictures that people put up.
It's not depicted on the inside of our planetarium as a horse
Yes, absolutely. All 88 constellations are depicted in the planetarium.
In some way or another,
Yes.
no matter how counterintuitive.
But this
So
latest,
there's a nice U-shaped asterism here, but it crosses in order. Here's a double set, another double set.
I think I had it laid
I don't
out.
know. Nothing pops together as a pattern in my mind.
It's a space filler.
Now, are the blue, the constellations, and the white words are the stars? Is that the difference?
Yes.
Yeah, it looks like it. Yeah.
Recorders, how do you pronounce that? Equulus?
Equulius.
Equalus.
Never seen,
Equulius.
never seen two U's in a row before. And Delphinus.
Delphinus the dolphin.
Right.
Ah, okay.
Right from the Latin, Ron.
It's like an upside down, screwed up dipper. But
It's often called a kite.
Oh, there you go. And
Now you see the two star names at the top, Sualison and Rodanev?
I was going to ask you, Chuck, to elucidate.
Yeah.
No, you
So
like this.
in the 1800s, there were some students studying double stars, and the nose of Delphinus, several of the stars in there are double, okay? And their mentor, what's the guy's name that found Ceres, Tom?
Oh, you mean the priest?
Yes.
Priest doesn't hit me right now.
Yeah, yeah, okay. Huh? Well, no, so anyway, the story was that their mentor, the TA basically that was helping them, was named Niccolò Cacciatore. And so in Italian, that means Nicholas the Hunter.
Right.
So they decided they were going to name these stars after them. So they said, well, you know, we can't call them Niccolò and Cacciatore. That would be a little too obvious. So they took Nicholas and they took the Hunter in Latin,
Right.
which was Nicolaus and Venator.
Right.
And they said that's still too obvious. So they spelled those two words backwards. So they ended up with Sualison and Rotanev.
Right.
And actually it was the guy himself that discovered Ceres. Oh, man.
Yeah, it's escaping me too,
Yeah,
Chuck.
yeah.
but
Anyway,
yeah,
he was the one that
this-
actually gave it those names to honor his assistant. But that was the story he put out. So it's one of those astronomy tall tales.
Yeah, right. Venator is a hunter, right?
Piazzi.
That's it. Piazzi. Yeah. I was just going to say the hunting dogs.
hunting dog.
Chara and Asterion.
Yes. Yeah. Condis Venatici.
Yeah.
Yeah.
In 1801 by Giuseppe Piazzi.
Yes.
Well, we're getting old, gentlemen. It's even worse than walking in a room and forgetting why you went in there. I try to call up names. We're down to the wire. We got gentlemen. Let's talk just briefly about a Labor Day. Let's see, through Labor Day, our beautiful museum that loves us and supports us has got the Rare Earths Minerals exhibit. And
It's really
Butterflies
nice.
Alive. And it's our own butterflies. Plus the Science Pub at Dargan's is 10 to, when is that? That's 6:30 to 8 tonight, I think. We should maybe do we ever do anything like that for an outreach? We could run one of those at a matrix.
Well, actually, Ron, on the next one in August, I'm giving a talk on meteorites
Okay.
Where?
at Dargan's.
Oh, at
Sorry.
Dargan's. I'll go to that one. Everybody else too. And
So early, it's hard to get in.
oh yeah, You're right. The sad news, if you want to call it sad, actually it's preparatory and being safe, is that August 5th is not going to be a live opening after all. We voted that down because surging, what is it called? BA2?
BA5.
Huh?
There's
BA5.
Yeah.
that won't even trigger the PCR test.
I'm
And they have
waiting.
now determined positively that the COVID virus was man-made.
Oh, that is bullshit.
Well, they were talking about that on
Thank you, Chuck.
YouTube.
We need to hear who they were.
Yeah,
I don't
that's just
remember.
total baloney.
It was some noted virologist. I don't remember his name.
Yeah. Well, when you get the majority of virologists coming to that conclusion, let us know. But that's bullshit.
All right.
And we can say that because they broke ground with that January 6th committee. That congressional committee has all those people from former Attorney General Barr saying the word. It's amazing. And effing, that's another one. So many F's. That's a new one-letter verb. Hey,
Okay,
John,
well, let's not get into politics here.
we're not gonna.
Okay.
Suckers.
I should be home. Amazing. I got to, but I'm going to try to save that very important link number, that huge code that we all have buried away, and we'll do it again next week. Take care of your lovely wives, the Pats and the Maureen's and the Bonnies, and we'll see you on number 73 to talk cosmology next week on the SBAU.
Americans had an open console coming Saturday.
Whatever you said, I believe.
Your sound failed you again. Anyway, to coin a phrase, Asta Nebula.